Hey guys, good morning. Welcome to the design thinking based discussion about the vibration problems in mechanical system. So most of the mechanical vibrating systems are used by engineers based on only the equations and the numerical solutions. Whereas in real-time issues are need to be understand from the user end as well as the constraints, different constraints and the practical feasibility. Now we are going to use the design thinking methodology, and with this methodology we are going to address the vibration problem in mechanical system. There is a design thinking 5 stages. We will find out how the design thinking helps us to solve the user end facing issues due to vibration. Right? So we will start with empathy.
Empathize is the first stage of design thinking in mechanical vibration problems. This stage focuses on understanding real-world experience of user, operators, and the system itself. Let us consider a practical scenario. An industrial workshop reports excessive vibration in rotating machine, causing noise, operator discomfort, frequent bearing failures, and increased maintenance costs. At this stage, instead of jumping to solution, we ask questions such as how does the vibration affect machine operators, what are the operating sound speeds and loading conditions, when do vibration increase during setup, steady operation or shutdown, what safety or productivity issues are faced. By empathizing, we realize that vibration is not just a technical issue, it affects human comfort, safety, cost and reliability.
We empathize the real-time problems facing the shop floor of the machines. So it is not only the technical term, also it affects all the safety aspects, resources. So this empathize helps us to use better solution and go with other stages.
Hello everyone, I'm here to talk about the ideal stage. So in the ideal stage, the main goal is to clearly understand and define the problem statement. So based on the observation from earlier, so the excessive vibration in the rotating mechanical system, which is operated near the resonance, so which leads to bearing credit failures and which reduce the operator comfort. So from this we identify the types of vibration, which is forced vibrations or resonance, and the possible some possibilities like misalignments, imbalances, and structural flexibility, and other things like constraints. So, in this stage, which is an important stage, because if we not understand the problem correctly, we are not able to give solution effectively. Even the calculations are correct.
So based on this ideal stage, we are understanding that resonance is one of the major factor. With this resonance, fatigue is going to happen. So these two terminologies creating due to the mass imbalance or the misalignments or the constraints. So here, if you sort out this area, you can minimize the major issues on the vibrating systems.
So hello everyone. Let me explain the ideal stage briefly. In the ideal stage, engineers brainstorm multiple possible solutions without immediately judging feasibility. For vibration problem, we can do shifting operating speed away from the natural frequency, or modifying the stiffness of the systems, and adding damping materials, and improving the dynamic balancing of the rotating parts. So at this stage, the creativity is encouraged. Like engineers compare alternatives based on cost, effectiveness, and ease of implementation and maintenance requirements. So this stage reflects the real-time practice, and the engineers with the multiple design options are evaluated without finalizing the solution. Thank you.
This is a great understanding of vibration system. We can modify the stiffness of the material. One idea we can take it out. Based on stiffness, the resonance will get reduced. Once we understand the resonance, the operating level can be shifted. So the system will have different natural frequency. We can operate the system in between the peak values or the higher natural frequency. So another way is adding some dampers. Another the imbalancing, the mass balancing, also the idea factor. So these are the ideas that we have taken from this discussion.
Hello everyone, I'm here to explain the prototype stage. In the prototype stage, the solutions are designed into practical engineering solution. For example, vibration absorber is designed and attached to the system, and the shaft balancing system is identified using trial plates, and also for analysis method, a finite element analysis is used. And prototypes may include a physical component or CAD design model and a simulation based solution. This stage helps engineers visualize the solution in real life.
So in this stage, we are understanding that by adding the observer, so we can reduce some amount of vibration. Before manufacturing, we can go with CAD models with phase simulation. From there, we can get all the possible modes of vibrations. With that, we can understand how the system will react in different conditions. Also, using if the system is already existing, we can using the trial error basis mass balancing. With that value, we can balance, reducing the vibrations in the systems. These are the one prototype what we are extracting from this discussion.
Coming to the final testing stage, under the real operating condition, the prototype will be evaluated. So what are the measures we will be taking is frequency amplitude, and the vibration responses, and the noise level, and the temperature rise in the VI. We generally know that if the vibration is reduced, the performance will be increased. If not, the design will be refurnished or refined, and according to that we will be delivered. So this engineering design is not a one-time process. It is an iterative process.
Generally, this design thinking also is an iterative process. Also, all the machinery components are having some version 1, version 2, different versions based on the increasing efficiency and reducing the cost and varying the light rating or the different materials. This is a cyclic process. Similarly, the machineries or vibrating machinery can be modified by studying all these ideas and define values and modeling CAD softwares. These things help us to understand how the machines are producing different vibration, different condition, how the already failure engine also giving some input data. With that, the engineers can modify new components, new materials, so that the engineers are able to reduce the vibration in the mechanical system. So this is how this design thinking helps us to understand the reduction of vibration in the mechanical system. Thank you all.
Thank you.